Good afternoon, everyone, ladies and gentlemen. Welcome to this exciting exploration of the advanced cleaning and data methodologies in data science. Today we are going to discuss some of the cleaning methodologies in the data science. So, before, whenever with the data science, we are going to perform some analytics. Before starting with the analytics, first of all, we need to gather the data. So whatever the raw data that we are getting, it is every time it is not in a clean format. There might be some missing values, there might be some the values, some outliers we can see. So how to deal with such kind of things? So we'll explore in this 2 day session. So let me start with the agenda. So today our agenda is going to first we'll introduce the topic. Here we are going to clean up the data. So what are all the cleaning techniques we are going to follow? So first we are going to clean our data. That means finding and fixing any weird stuff, any unnecessary stuff, like filling any missing values with some other pieces and getting rid of some extra copies of the values. This way we can handle our data with the top-notch shape for the analysis. So then next we are going to discuss about the how to enhance the data quality. So for enhancing the data quality, so we already discussed how to handle this data, how to identify the unnecessary values in the data. So we are going to see in the enhancing the data quality, and then we'll discuss the optimizing features, the presentation. So here now we are going to make our data more understandable. So whenever we are dealing with the data, so our system or our libraries or Python program should understand the data very well. So for that, we are going to make our data more understandable. Here we are thinking perspective of like giving our data some makeover to the data, fixing how we can talk about different things, making sure our data setup in a way that makes sense to our computer programs. And then we'll discuss the boosting the computer smarter, like improving the model performance. Improving the model performance is something like the boosting the computers smarts. Like this is going to be the cool part. By doing this first two steps, we are making our computer program smarter. Like they understand the things better, perform better, and become really efficient at what they do. And then we are going to see the some of the facilitate interpretability and understandability. So here we tell the clear data story. So here we are not only just dealing with the numbers here. We want to tell a clear story with our data. This is the important so everyone, not just the data experts, can understand what our data is telling. So any normal person, like the business takeovers, or anyone can understand this data. It's like a storytelling, and also ensuring the reproducibility and compliances. Like here, we are going to following some best practices to keep our data secure. Like now, we are going to see our first part to deal with the data, handling the data. So, firstly, while handling the data, first of all, the most common methodology that we are going to follow is dealing with the outlier detection and handling. So, outliers are something which is out of the data, like some extreme values or very minimum values or maximum values. For example, if you are analyzing some student data, student marks data, so all the students are lying at between the marks of the test score at 60 marks or the 60 to 70. But some people are having some extreme scores, something like 99 marks or some people might have some minimum of the minimum values, minimum marks like below 20 or somewhere 30. So most of the students are lying under the 60 to 70. So these are some extreme values. So how we are going to deter this outliers? So this detecting the outliers are the crucial step into data analysis and machine learning. So ensuring this quality and reliability of the result is the most crucial part. So outliers are the data points that deviate significantly from the rest of the data, and they can distort the statistical analysis and machine learning models. So we'll discuss some of the techniques how to handle with outliers. One is the first thing we are going to do the visual inception. So in the visual inception here we are going to handle the data with the help of some statistical methods, example Z-score or interquartile range. So then we are going to decide whether we need to remove these outliers or need to be transform them or impute a new value in place of the that outlier value, that extreme values we are going to replace with some standard values. So in the next slide, I will show you some visual representation, how we can do some visual representation of these outliers. So here we have the different plotting like scatter plot, box plot, and histogram block box plot. So this visual inception, we are going to use some box plot and scatter plot or histograms to visualize and insert the data for any usual patterns or data points. And next, we are going to take the statistical approach. So some of the statistical methods we are go some of the statistical methods mostly we are going to follow is the one is the Z-score. So with the help of the Z-score, we can identify the data points that fall outside a certain number of standard deviation from the mean. And then we have the one other method, most commonly used method, which is the IQR, which is the interquartile range. So in this box plot, this is the visual representation of the blocks for the center pattern. So with this interquartile range here, we are going to detect the outliers based on the distribution of the data between the first and the third quantile range. Here we have the Q1 and Q3. So we are doing some visual representation of the box plot and which all data points lie out of this interquartile range. Okay, I have one message about the regarding the explain the scatter plot. Okay, I will come to the part, the scatter plot. So here, coming to this interquartile range, here we are going to deal with this. We are going to visualize our data in the form of a box plot. So where we are going to check for the median value. From the median value, we are going to take the quantile 1, quantile 2, and quantile 3. So which are all data lies above out of the quantile 3 range. We are going to consider this data as a these data points as outliers. One more question, what is the frequency plot? Yes, frequency plot, we know, which is nothing but we can say it as a histogram plot. So where we are going to like, for example, I am measuring, can say that for example, I'm not taking, I don't want to complicate. So just I'm going to brief it in a normal way. We have the students, a class, we have the students of only male and female. So I want to check the frequency. So what is meant by the frequency? The count of the male candidates and the count of the female candidates. What is the frequency of male candidates in the classroom? So there might be some 10 students or 20 students, there might be some frequency. In the same way, what is the frequency? For the every unique value in the particular column, in the gender column, we are going to take the frequency, plot a frequency graph. And this frequency plot, it's a very small example. Here we are going to deal with some huge data. So there we are going to take the histogram plot where we are going to check the frequency and making it as a some we are checking with some distributions. Coming to the scatter plot. So here is the example of the scatter plot here we have. So with the help of the scatter plot, we can identify where my data points are lying, some visual representations. So let me zoom this. So here, for example, we have the x-axis, we have the speed. Is it speed? It's not clear. For example, we can take it as some examples like we have some, we can take an example of the wine. So we all know the taste of the wine depends upon the age of the wine. So if the age of the wine is like it lies somewhere around 10 years means we can say that taste lies at some acceptable criteria. If the age is going on increasing in the same way, our taste, the acceptance rate of the taste will also be parallelly increasing. So in this way, we are going to do some visual representation of the data to check where our data points are lying actually. Does my data point with we can identify some patterns with the help of the scatter plots. Okay, two more questions. So for the coming to the certification of this attendance, people don't get the certification for this orientation. So these events are for the enhancing the subject towards one particular field. For example, if you complete to enhancing ourselves subjectually. We are not going to provide any certificates. My slides are looking blurred because the image quality is very low. I think the issue is with only this one single slide. It will don't repeat in the future slides. For example, what I am trying to explain is with the help of the scatter plots, we can identify some patterns of the data. Like with normally looking into the data from 1,000 records or 2,000 records, we can't identify pattern. Okay, I think I try to make my voice more clear. Okay, we can identify some patterns of the data with the help of the scatter plot. So with the normal data values, by simply looking into the column values, like some all the numeric values, we can't identify, we can't say that the maximum data points are lying at this particular position or that particular position. So where we can identify some patterns with the help of the scatter plots. That's the main goal of the scatter plot. And coming to what are all different techniques that we are going to use for detecting, mainly to identify this. So once we have identified, we can go with the how to impute a new value in place of the outliers. So first we need to detect the outliers. So for detecting, one is the visual inception. With the help of visual inception, we can identify the outliers. And next thing we have the statistical methods. So some of the statistical method, one is the Z-score and one is the IQ, interquartile range. I think we already discussed the statistical methods which two, Z-score and IQR. And next thing we have the machine learning models are also available. So we don't do this boring stuff manually. So we know the techniques how to handle these outliers. So we can automate it with the help of the machine learning models. So we have the most commonly used two models. One is the isolation forest and one is the one class SVM. So abbreviation is the support vector mission. So coming to the isolation forest, so this model identifies the outliers by isolating them in a binary tree. And next thing we have the support vector machines, one class support vector machine. So here we are going to train our data with the normal data, the normal actual data, and we are going to train my model with the help of how to identify the outliers. We have so this one plus SVM is built on top of some statistical methods. So where how it has the capability of identifying the outliers and some deviations from the normal patterns. So actually our pattern lies at our data lies at one particular position. So at some particular location. If here also we can see, so some four data points are lying completely out of the range. So all the data points are lying here. Some four data points are lying. So this is called out of the range. So we are going to train our support, our model, our machine learning model with the normal data. And this here we are with the help of this normal data. Here we are going to identify the outliers and some of the deviations from the normal pattern. And next thing we have some other machine learning models which is the distance based methods. So by like here we can see we can identify some distance. It is away more it is away from the actual data. So some of the distance based methods we have which is the k nearest neighbor KNN, which is the most popular one, which identifies the outliers based on the distance to their k nearest neighbor. For example, you can name it as a k, k1, k2, k3, k4. So here you can identify the nearest neighbor. So all these are nearest neighbors. These data points are lying away from these points. So we can identify in this way. One is the k nearest method, and one more method we have, which is the DB scan. So this DB scan classifies outliers as the data points in low density regions. So here there is a very low density. Here we have the very huge density. Population is lying here. So here it's a very low density. So one most commonly used methods, one is the k nearest neighbor for checking the distance, and one is the DB scan for checking the density of the data points in that particular region. And also how we can handle this data. The this we need to impute some more values. For example, we need to remove these values and we need to replace these values with some other values. So how we can impute a new value? So replacing these outliers with some values such as mean, median, or mode values. So once we are checking the mean of our column value, we can get some mean value. We have some median or mode value. The highest frequency value simply. Mode is nothing but the frequency, highest frequency, or you can say it as the highest counter. You can replace these values, these data points with some mean of the highest frequency. Here we can see this is the highest frequency data point that we can identify. So we can replace these observations, this observation value, the data value with these values, some other values. So different methods we have. Which method we are, so whether we can replace this value with a mean value or median value or a mode value. So and also we have some other advanced imputation methods are also available, like regression imputation and estimating the values based on the other variables, some other variables. Like we don't have our data set consists of the multiple column names. So here we are working on upon this some two columns. So when we are working on two columns, we can impute a new value in place of this observation. We can consider some other column names, nothing but the variables. It is one of the terminology we use. So we can take the reference of the some other variables. Based on that variable data, we can replace the value. For example, if the it's a simple example. If it is a male candidate, we will use the value as the 5. If it is a female candidate, I want to replace the value with the 10. So in this way. So these are some of the imputation techniques. So once we have imputed a new values to these outliers, then we are going to do the transformation. Transformation means like applying some transformations, like logarithm transformation. If you apply the log function on these data points, we are going to get a new outcome of the value. So some transform. Why we need to do these transformations? Because we may understand the data very well to our program. Computer programs should be capable of dealing with data. So that's why we are going to do some transformations, converting our data, like transforming our data to make the distributions like symmetric. Like when you draw any normal distribution, so it should be symmetric. If you are dealing with, if you are not transforming the data and you want to simply plot a histogram and want to plot a simple normal distribution, you can't get a proper symmetric data. So that's why we are going to transform our data with the help of any log functions, and we have some other functions which is min scalar, some other techniques we have. With the help of that, we need to transform our data. And once we have done with the transformation of the data, we are going to do the capping or flowing. One of the method to impute, like to impute the data, which is like setting, simply giving the upper limit of the value to the higher, to the outer outliers, or giving some lower limit value to the outliers. So this is one way. And also one other way we have, which is the removing those outliers, completely remove these outliers. So removing these outliers from the data set is simply like to be an error in our data finally. So it's better, it's a best, the best way is to impute a new value rather than the removing these outliers. So if we remove these outliers, there might be, we can get, we, we may get some errors at the in the report, at the final report. So it's a better way to fill some value, like as we discussed, some mean value, median value, or some other values, different techniques we can use, or else we have some machine learning algorithms to do that. And also some of the statistical methods we have to impute this data, which is such as the median and median value, simply using the median value, or MAD, nothing but the median absolute deviation. So instead of using the mean, so when we are using the mean value and standard deviation value, we are going to, our data will be not as symmetric. So for that, we mostly prefer to use the median and the MAD, which is nothing but the median absolute deviation. So and some we have some advanced models, like training with the machine learning models, like with the very less sensitive to the outliers. If our data is consisting the more number of outliers, so our machine learning models might not work very well. So when we have the very less, like sorry, when we have very less sensitive data, which is like you can't able to identify the data, like each and every time, like want to impute the data to handle this outliers. So there we can automate the things with the help of the machine learning models. So because our models have trained with the large amount of data, not only some thousand observation. So we know, like today we are using the chat GPT. So it's a very advanced model. Why we are calling it as a very advanced, com- complicated model? Because they train the data. The main thing is it's a generative model, simple generative model. You can search in the Google. The simple generative model they are using. But the main game place here is the how much data they are feeding. They are feeding some billions of data. So that's how we can. So when we are training our data, we are going to train our data with the large amount of data. Then we can very easily identify the outliers. Like we can deal with very sensitive amount of the outliers also. And next thing, we need to monitor continuously. The continuous monitor is must required. Like there might be a new data points, or else some unseen patterns when you are doing the first analysis. These things might happen. So continuous monitoring is a best practice, and also for better to follow some iterative approach, like repeatedly checking or detecting the outliers will makes the good practice while we are identifying the outliers. So the final motto we need to understand here is like remembering the which choice of method that we are going to use for detecting the outliers. So how we are going to handle it, all this, it depends upon the characteristics of your data, how you are going to handle. So for all the data sets, I We are not going to simply follow only one single method. So it depends upon your data and your goals and your analysis model. And also, one thing we need to keep in mind is try to use the more number of models. Try to apply the all the models and go with the best performance model. Like simply applying one single method and working on the, it's not a good practice preferred. And this is about a complete understanding of the outliers, like detecting and handling the outliers. And while cleaning the data, the next part we are going to see is the handling the missing data. For example, I have some missing data. So how can I impute any? So how can I fill that missing value with some other value? So missing data imputation. So here we are going to use some advanced imputation technique, something like the k-nearest neighbor. As we discussed when we are dealing with the outliers also, like in place of the outlier value, we are going to deal with some k-nearest neighbor value. We are going to fill the nearest neighbor value. We are like removing this. But this is about already data is there, but it is an outlier. But now we are seeing which is there is no value at all. The missing data values. For example, this is my data set, but some data points are missing. So, like here we can use some methods like filling your data with the mean, median, or mode imputation we can do. And forward fill and the backward fill is one more approach. Like forward fill, for example, if we look into this first variable, so the data point, the observation number 8, the one data point is missing in the variable 1, observation number 8. So forward fill is something like you can fill the value of the 7th observation to the 8th observation, or the value of 9th observation value to the 8th observation value. So this thing we call it as one is the forward fill and the backward fill values. And also we have some models, some machine learning models, which is the linear interpolation. So by estimating the missing values, like by interpolating between the observed values and using the linear, like here we can say it as a we are drawing a simple linear line. By observing the values over here, we can decide which is the best value to fit by identifying some pattern in the data. And also we have the hot deck imputation, which is replacing the missing values from a similar donor. So, like observations often choose based on the similarity in the other variables. So, these are the some variables like if we have some similar variables, similar columns. So, by checking the similar values from the other variable names, we can fill this data point. And we have the k-nearest neighbor and matrix factorization, SVD method, and regularization imputation and deep learning imputation like with the help of the neural network predicting the missing values. So which value might come? So we can predict, right, with the help of by training our model with the huge amount of data, we can predict actually which data might be missing. Like how we are doing the aptitude, like aptitude in aptitude and reasoning questions, we can see which there will be a question mark with someone with missing value, which value we can replace at this position. So, like, it's a simple example, but here we are dealing with the machine learning models. So, we can use some deep learning, which is the most advanced machine learning models that we are going to use. So, we are going to fill some good predictor value over the missing values, and also some weighted imputations. And if you have some domain knowledge, for example, you are dealing with some banking data. So in banking data, so we don't directly impute the value, like you have the knowledge of that particular data set. So if you have some domain knowledge expertise, when it is something like a healthcare or the banking data you are dealing, so if we have some idea, we know so which value to be replaced. A common value we can follow, right? Like what I said, if it is a male, I will replace it with the value of all. If it is a male, I will replace it with the 10. So in that way, if we have some domain knowledge, we have that understanding which value to be replaced. And also dropping the missing value is one of the way. simply dropping, like clearing all the missing values. You can select all the variable, all the columns, and drop all the observations where they are having the missing values. So the observation 2 is not having any single missing value. So in this way, only observation 2 is not having the missing values. So we are going to lose all the remaining observations. So dropping the missing values is one way, but it is not recommended way. So replacing the missing values is the best approach than dropping the missing values. And also we have the time series interpretation. So using some time series interpretation methods such as the cubic fill interpretation or estimating the missing values, we have the different time series machine learning models. With the help of those models, we can impute the new values. So this is one way of dealing with the imputing the missing values. Next, we'll see how to handle the duplicate values. For example, duplicate values are something like, let me show you in this slide. The same value. Do we have any duplicate value here? Okay. Right now, I don't have any duplicate value. For example, I have one observation 2 and the column number 1. At observation 2, the data value, for example, I have 2 as the data value. And at the observation 3 also, I have the data value as 2, the same value, which is nothing but the duplicate value, the repetition of the same values. So it is not required. It depends upon your business case scenario. So how can we handle these duplicate values? So for handling the duplicate values, we follow the different methods. One is the identifying the simply identifying the unique values. You can go with the identifying the unique values, or you can sort your data. Sorting means like a ascending order or descending order. You can sort your data like this particular column or the considering all the variables. You can sort the data and remove the missing values. These are some of the easier techniques. And also we have the dropping the extra duplicate values, removing the extra duplicate values. So we have the Python codes, a single line of code to deal with these things. Like simply we have the one advanced pandas library. So with we have the simple methods like drop underscore duplicate method. So by applying those methods, we can like method or a function you can say drop underscore duplicate method. You can drop to a missing value, duplicate values, and there might be a chances sometimes there might be a duplicate values, but it is coming very partially, very occasionally the duplicate values you are seeing. So there is it depends. There is no such thing called I should completely delete these values or not to be deleted these values. So accordingly, we need to deal with such kind of data, or else we can do the aggregating the values with a previous value already we have one value. You can do some simple aggregation, you can add with one more number with one plus one. So two times you are getting two. So you have identified two as the two times duplicate value. So the second coming two, you can add plus one. So the two value is going to be the three. Like doing it is a simple example, but we can do some aggregation methods like not only this simple thing. So for that, we have some aggregation method like aggregating with the mean value or with some value or a median value. You can do the aggregation and also preventing the duplicates. How you can prevent these duplicates? So using some validation rules, like you can implement the data validation rules to ensure that the new data to be a specific it should reach it should satisfy some specific criteria like preventing and introducing the duplicate values. And also one more way of handling these duplicate values, we have the fuzzy matching, with the help of the algorithms, and also the record linkage and quality checks, data profiling, documentation, handling duplicates in pandas is very easy. Like we have the simple methods. One is the drop underscore duplicate method, and in we can pass the different style of parameters while handling this data inside a specific method. So always at the last be cautious about how you are going to handle these duplicate values, as you are removing these values or you are aggregating these data values. So it impacts a lot when coming to your analysis. So you should try to opt the best approach. Like, is it the better way to remove the values or do some aggregation techniques on the value? So choose the best approach. It depends upon your dataset characteristics. So next we'll see some of the data transformation techniques. As we discussed, we need to transform the data. So coming to the transformation of the data, like we have the different techniques to transform the data. One is scaling, min-max scaling, and standard scaler. So we have different methods for scaling the data, like normalizing your data. So coming to, let me show you some pictorial representation of these scalings here. So you are going to do, we can do the scaling with the help of methods available, which is the min-max scaler, standard scaler, and the robust scaler. We can apply a different, like you are going to transform your data for the analysis purpose, like as we discussed, like this coming to, let me go come one by one, one by one method. So first thing we have the scaling method, which is the standardization simply by checking the Z-score normalization. So this Z-score normalization scales your data to have a mean value of zero. Like you have some negative values and some positive values. The mean value should be zero there. So whatever your data might be. So applying these formulas, you are going to transform your values to some minor negative values and positive values. There your mean value is going to be the zero and standard deviation will be followed as the one. So all these techniques, there is no need of implementing these formulas in the programming terminology. We are simply going to use the libraries. We have the scikit-learn library to deal with such kind of things. So in scikit-learn library, we have the standard scalar method. So here we can see, whenever you see this open parentheses and closed parentheses, these are the some of the methods that we use in the the Python methods. So we can go with the standard scalar method, like standard scalar method, and you can do. So it follows the proper mathematical approach to transform your data into as per the standard scalar techniques. And also one more thing we have, which is the min scalar. So coming to this min scalar, your data values ranges between the 0 1. So from 0 to 1 only, all your data are transformed. Whatever your values might be, some if you if you look into some account statement, account balance, credit balance, and debit balance, so there will be some numerical values. You are going to, with the help of min scalar, converting all these data points into the specific range of values from 0 to 1.